This is video 2 about bend allowances and bend radii. In the first video I explained what exactly bend allowances and bend radii were, and now I want to put it into practical use. This object in red here is what the object will look like when it's completed, okay? And this is just a fictitious object, but what you need to determine is how long your layout needs to be to achieve this final desired length here, okay? And you can see that X, Y, and Z in this object, the length will not change, okay? The main length that you need to calculate will be L1, okay? And this is the length along the neutral axis, and L2. And you can see that these, of course, are at two different angles, and also this inside radius is different, so you need two separate calculations. And then when you find L1 and L2, you just add X, L1, Y, L2, and Z, and you get your total length. Now you can click on all these in your drawing and determine this. For example, you can use the dimension angle to dimension the angle between here and here. And if you can't remember how to get a precision of 4 decimal places, you simply click on the angle, right click, and then adjust your precision here, okay? But you want to use 4 decimal places, okay? And these lines that I got the angle from, these are actually drawn from end point to end point of the straight line, okay, that you can see there. And the bend radius is, like I said in the previous video, the inside radius. You can simply click on that, go to properties, and get the radius from there, okay? And also the thickness of the object will need to be determined, and you can just use the DI or distance command to determine the thickness of the object, which is 0.5 in this case, okay? Now all these numbers just simply need to be plugged into the formula. You'll be given a K value of 0.4 in this case, and they are all just simply plugged in. And for example, radius 1, which is the bend radius, is 0.5, K is 0.4, thickness is 0.5. The approximation for pi in this case is 3.1416, and the angle is 81.6126, okay? And I get a final length of 0.9971, and sure enough, if I click on that line and go to properties, that length is 0.9971, okay? Now you'll have to show all your calculations, but what you and you may not actually do this on CAD for your exam, but you need to be careful when you're calculating these values, and it goes back to elementary algebra. Please excuse my dear Aunt Sally, and P is parentheses, E is exponents, then multiplication, division, addition, subtraction, okay? And it needs to go in that order. And why I bring that up, you need to do the inside parentheses first, okay? So you need to multiply 0.4 times 0.5, and then when you get that value, you add 0.5, okay? And then you multiply that value times 0.2, and then you can finally multiply that value times pi times the angle, and finally divide that whole number by 360. It has to be done in a certain order, or you'll get a different value, okay? But once you determine that, and you can see also what this value up here is different, but it uses the same formula. You just plug in a different angle and a different bend radius, and you come up with L2, okay? You simply just add the X dimension, L1, Y, L2, and Z, and you come up with your answer, okay? Now if you are given a paper exam, you will be given these values, or it may be given in AutoCAD where you have to determine those. But be familiar with the formula. I will give it to you, but be familiar with how to use it, and proper implementation in a calculator, okay? And always write out your values in this formula here, okay? And also your total length, okay? And that concludes this video on how to calculate bend allowances.